In this video we're going to look at how we can describe the motion of a particle moving in the xy plane. So, as an example to get us going, we've got a particle moving in the xy plane so that at time t seconds, where t lies between 0 and 5, its displacement from the origin is given by the vector r of t, where r of t has an x component of 16 minus t squared and a y component of 0.1 t cubed. So it's quite easy to work out the displacement of the particle at a variety of times. So for instance, we could work out the displacement at t equals 0, t equals 1, t equals 2, t equals 3, t equals 4 and t equals 5. So if, for example, when t is equal to 1, the x component of r is going to be 16 minus 1 squared, which is 15, and the y component of r is going to be 0.1 times by 1 cubed, in other words 0.1. And having worked out our table of values, we can then show the position of the particle every second on a path so that we can get an idea of the path of the particle. And I've done this using GeoGebra just to give it some dynamics. So here we've got t equals 0, we've got the point 16, 0, and we've got each of the points plotted for t equals 0, t equals 1, t equals 2, t equals 3, and t equals 4, and t equals 5 at the end. And if we join these points up with the curve, we can see the path that the particle is following during the time between 0 and 5. So, we've so far seen that we can plot the points and we can draw the path of the particle. The average velocity of the particle between two times is quite easy to work out, because all we need to do is remember that the average velocity between two times is the change in displacement between those two times divided by the length of the time interval between the two times. So if we want the average velocity between t equals 1 and t equals 3, we take the final displacement, which is r of 3, take away the initial displacement, which is r of 1, and divide it by the length of time, which is 3 take away 1. So r of 3 is the vector 7, 2.7, r of 1 is the vector 15, 0.1, and the time interval is 2. The vector 7, 2.7 take away the vector 15, 0.1, gives me minus 8, 2.6. We've got to then divide that by 2, and we get the average velocity between t equals 1 and t equals 3 is the vector minus 4, 1.3 meters per second. Now, to find the velocity of the particle at an instant, we must remember that the velocity is the derivative with respect to time of the displacement. So to find the velocity at an instant, we need to differentiate the vector r. So we've got to differentiate the vector 16 minus t squared, 0.1 t cubed, with respect to time. Now differentiating vectors is nice and easy. We simply differentiate the x component and differentiate the y component separately. So, in this case, the x component of the velocity will be given by the derivative of 16 minus t squared, and the y component of the velocity will be given by the derivative of 0.1 t cubed. In other words, the velocity is given by the vector whose x component is minus 2t and whose y component is 0.3 t squared. So for example, when t equals 4, the velocity is going to be given by the vector minus 8, 4.8 meters per second. Now we also know that the acceleration at an instant is the derivative with respect to time of the velocity. So if we wish to work out the acceleration, we need to find the derivative of the velocity expression. We need to find the derivative of the vector minus 2t, 0.3 t squared. And again, we do this by simply differentiating the x component separately and differentiating the y component. So the derivative of minus 2t is simply minus 2. The derivative of 0.3t squared is 0.6t. So the acceleration vector is the vector minus 2, 0.6t. So, for example, when t equals 4, the acceleration of the particle is given by the vector minus 2, 4.8 meters per second squared. Now to finish this video, what I'd like you to just do is pause the video, because you're going to be doing an exercise just on using these ideas. So we've got a particle moving in the xy plane, so that at time t seconds, where t lies between 0 and 8, its displacement from the origin is given by r of t, which is the vector t minus 6 with x as the x component, and 0.05 t cubed as the y component. And the motion of this particle is shown in the video we've got here. And what you've got to do then is to find the instantaneous velocity and acceleration of the particle when t equals 4, and also to find the average velocity of the particle during the 8 seconds of its motion. So pause the video at this point, answer this question, take it along to your next lesson, and then we have finished the video.